Hello, welcome to Algebra 1, Unit 3 review. Let me get the screen shared here for you. So today we're going to go over the review for Unit 3, which is also known online. If you're going through the online book, it's Module 2B, and we're talking about linear systems in this unit. So we're going to start by looking at three different graphs here. And these are not systems, these are just lines. And so we want to review how to graph a line because you need to know that in order to be able to solve for the systems. So here it says to graph using a table. And so all that means is we have to fill this out with the X and Y coordinates. Remember, these are going to end up being the coordinate points that we use to plot on the chart where everything goes. So you're just going to pick some numbers to plug in, and whatever you get is what you're going to use to plot the points. So I'm going to put in 0, 1, and 2. All right, so that's going to start off with -3 times 0 plus 4 equals 4. So I'm going to put a 4 here. Then -3 times 1 plus 4 is going to be 3. Oops, nope, sorry, not 3. Let's see. I always advise and encourage the use of a calculator. So we're going to go ahead and do that, especially since I just was putting the wrong answer in. All right, and then -3 times 2. -3, open parentheses, 2, close parentheses, plus 4, hit enter. So this is what I entered into the calculator. And what I got was -2. -2. So those are my 3 points here. And I'm going to go ahead and plot them. So I've got 0, 4, 1. So I'm going to go to the right and to the left. That's my first number, the X value, 0. So it means I'm not moving at all. And now my 4 is my Y value. Since it's positive, I'm going to go up 1, 2, 3, 4. This is my first point. Then my second one, I have a horizontal value of +2 and +1. This is my second point here. Then I have an X value of +2 and a Y value of -2. So I've actually got 3 points here. There is no need to get more points than that. Technically, all you need are 2 points to graph a line. As y'all know, I'm not very good at keeping my lines straight. So hopefully on your paper, when you're drawing it yourself, you're going to use a straight edge, the edge of the book, something to help you get a better line. Make sure you put arrows on either end because you know that a line goes on forever and ever in both directions. Okay, so now we're going to graph using the X and Y intercepts. And what that means is we're going to plug in 0 for the X and 0 for the Y. And then solve. Because if we have an X intercept, then we know we have a 0 on the Y spot. And if we have a Y intercept, we know we have an X or a 0 in the X spot. So since we know we have these zeros here, we can plug it in. So this one is when we have a 0 in the Y spot. So it's going to be down here. This one is when we know we have a 0 in the X spot. So that's this top one here. So we're looking for the Y when we're finding the Y intercept. So 3 times 0 is 0 minus Y equals 6. So that's just minus Y equals 6. And then to undo that negative, I have to switch the sign of both sides. So it's going to be Y equals -6. So if my Y is -6, that's going to go right there. And then 3x minus 0 equals 6. Well, that's just going to end up being 3x equals 6. Divide by 3 on both sides, x equals 2. So I'm going to put a 2 here. So my first point is to go to the right 2 and up 0. So this is my first point. And then my second point is to go to the right or the left is 0, but to go up 6. 1, 2, 3, 4, 5, 6. So this is my second point. And now I need to try to connect the dots. Okay. They will eventually cross. I did not do a very good job of keeping it straight, but they will eventually cross. All right, so we have got another one here, graph using the slope and y-intercept. So that means that we need to get this into the slope-intercept format. I'm going to come over here. I'm doing it in blue so you can tell the difference. 2x plus 3y equals 12. And to get it into slope-intercept format, we solve for y. We're going to get it into y equals mx plus b format. So I'm going to have 3y equals 12 minus 2x. Now I'm going to need to divide everything by 3. So I'm going to be left with y equals 12 divided by 3 is 4. Negative 2 divided by 3 is negative 2/3, and then x. Now, officially, to have this in y equals mx plus b format, you would want to have the variable term first and the constant last. Now, in order to graph this, we know that our b is 4, which means our y-intercept is 0, 4. And then we know our slope m is negative 2/3. This is going to be our first line with a negative slope, and so that means it's going to be going the opposite. Well, no, they all have negative slopes. So let's see, 0, 4, 0, 1, 2, 3, 4 is right here, just like before. And then we're going to go down to 1, 2, and over 3. 1, 2, 3. Down 2 and over 1, 2, 3. Okay. So this is a much calmer slope, not quite as intense, not quite as steep. Let's see how I'm going to do a very bumpy line there, but a line nonetheless. You get the idea. So those are our 3 graphed lines, and what you'll have to do is you'll have to be able to identify on the computer the line that matches the information that you're given. So you want to be able to graph these by hand so that you can tell which line is which. All right, so here we have 3 more questions. We need to solve this system. So this is when we get into solving our systems. We're going to solve this system through graphing. So that means we need to graph each of these and see where they intersect. So y equals 2x. This is already in y equals mx plus b format. What is our b? Our b in this case is 0, and m in this case is going to be 2 over 1. So we're going to, right here at the intercept, excuse me, at the point of origin, the 0, 0. And then I'm going to go up to 1, 2, and over 1, up 2, and over 1. And then I know that I've got a line kind of like that. And then here, my b is going to be 1, and my slope is 1 over 1. So that means my y-intercept is right here, and I'm going to go up 1 and over 1, up 1 and over 1, up 1 and over 1. So this is my slope. And to solve the system of equations is to find out where the lines intersect. So we know that they're going to intersect right here at where I went to the right one and up 2. So that is the coordinate point, the ordered pair 1, 2. Now, we need to verify that because obviously my graph is not perfect. It is not exactly right, but even if you do have a perfect graph, you should still always check this. And the way that you're going to check it is you're going to plug it into each of these statements to see if it's true or not. So 2 equals 2 times 1. I plugged the 1 in where the x was and the 2 in where the y was. You should be using your calculator, but I can tell you that that does verify. All right, so next is 2, where the y is, equals 1 plus 1. Again, use your calculator to verify, but 1 plus 1 does equal 2, so we did get that correct. All right, solve by the substitution method, and that means what we're going to do, this says y equals right here. So we're going to take that and plug it in where the y is. So I'm going to have 4x plus, instead of writing y, I'm going to write 2x minus 4, and then finish my equation equals 26. Now, my first step in doing this is to combine like terms. I want to simplify my equation. So it's going to be 6x minus 4 equals 26. Then I can begin to solve. I want to get all my constants over to the right. So I'm going to have 6x equals 26 plus 4. And the 4, because it was on the left, it's moved to the right. If it changes sides, it needs to change signs. So the negative 4 becomes a positive 4. So that's 6x equals, I'm going to use my calculator here, 26 plus 4 is 30. And then what we need to do is go ahead and undo what's being done to the x. What's being done to the x is it's being multiplied by 6, so we need to divide by 6 on both sides. So x is going to equal 30 divided by 6 is 5. Now, that only tells us one part. Remember, our answer is going to be an ordered pair like this. So that only tells us the x. It does not tell us the y. So in order to figure out the y, we need to plug in y to one of these equations and figure out what the x is going to be from there. And in order to do that, I think I'm going to use the second equation, 4x plus, oops. You know what? I don't want to use the second equation. I want to use the first equation. How about that? Y equals 2 times 5, because x equaled 5, so I'm substituting the 5 in here, minus 4. So y equals 10 minus 4. Oops, I can just use my calculator. That's what I should have done in the first place. 2, open parentheses, 5, close parentheses, minus 4 equals 6. Y equals 6. Now, I always encourage you, especially on tests, to check your work and make sure that you got this correct. There's no reason to be unsure. You should always verify, especially when it comes to making sure your answer is correct on the test. And since we used this equation to find the y, I want to use the lower equation or the bottom equation to verify my answer, just to make sure it's good. So I'm going to do 4, and then I'm going to plug in what I got for x, which was the 5. So 4 times 5 plus, what did I get for the y? I got 6 for the y equals 26. So I'm going to plug just this left side of the equation into my calculator. 4, open parentheses, 5, close parentheses, plus 6. And I didn't need parentheses when I'm just adding it. So my answer is 26. So 26 equals 26. That checks out. I'm good. All right, so on to this third equation here. We have solve by linear combination, which is another way of saying elimination. Okay, we want to solve this through elimination. This already has an exact opposite for us, so we don't even need to multiply or modify these equations at all. We can just go ahead and start adding. So 4x plus 3x, we know they have a common term of x, so I can go ahead and write that down and then add my coefficients. 4 and 3 is going to be 7. You can use your calculator as well for that, equals 19, and 9 is going to be 28. So 7x equals 28. Now, how do we solve for this? We're going to have to divide both sides by 7, so x is going to equal 4. So I've got the first part of my ordered pair. Now I need to find the y. How do I do that? I substitute x into one of these equations, and let's see which one I want to use. I don't see that one is going to be easier than the other, so I'm just going to use the top one. 4 times 4 plus 3y equals 19. 4 times 4 is 16, plus 3y equals 19. 3y equals 19 minus 16. Y equals 3, 3y equals 3. Divide by 3, y equals 1. Now, what do we need to do? Our last step, remember, we need to check our work. And since we used the top equation before, we want to use the bottom equation to check our work. So 3 times 4 minus 3 times 1 equals 9. So I'm going to plug this into the calculator. 3 open parentheses 4 close parentheses minus 3 open parentheses 1 close parentheses, and I hit enter, and I got 9, which does equal 9. It checks out. I got the correct answer. So let's see here. 4, 1 and 4, 1. Then I have 5, 6 and 5, 6, and I have 1, 2 and 1, 2. So I got all 3 correct answers. Those orange answers were pulled from the answer key. All right, so we're going to solve this system by linear combination, aka elimination. So this time I have them, they're in standard order. So my X term is first, and then my Y term, and then my constant. But I don't have any exact opposites in this. So I'm going to have to manipulate it in some way. Matter of fact, I don't see anything that even has opposite signs. So I'm going to actually have to multiply both of these by something. I can't just multiply one of them. I'm going to have to do both of them. So I think what I want to get rid of is going to be the y's. So I'm going to multiply this top one by a positive 2 and the bottom one by a negative 5. All right, so if I multiply this out, my first one is 2 times positive 2 is going to be 4x. 2 times negative 5 is going to be negative 10y. And 2 times negative 4 is going to be negative 8. And then 5 times negative 5 is negative 25x. Negative 5 times negative 2 is going to be a positive 10y. And negative 5 times 11 is negative 55. Now I'm going to combine these. I'm going to add them up. So I know I'm going to have my x here. My y's are going to cancel out. So I just need to combine my coefficients here for my x's. A positive 4 minus 25 is going to be a negative 21. And that makes sense because we have different signs. We need to find the difference. 25 minus 4 is 21. The answer carries the sign of the larger value. All right, negative 8 and negative 55, same sign. We're going to combine. But also using my calculator, I can verify that that's negative 63. Negative 21x equals negative 63. We're going to divide by a negative 21. So negative 63 divided by negative 21 equals a positive 3. X equals 3. Okay, we still need to figure out what the y is. So what I'm going to do is plug this into one of the equations, and I'm going to choose the bottom equation. 5 times 3 minus 2y equals 11. Okay, 5 times 3 is 15 minus 2y equals 11. And then I'm going to do negative 2y equals 11 minus 15. Negative 2y equals, let's plug that into our calculator, 11 minus 15. We should have done that for 5 times 3 as well. I'm sorry to forget that. All right, so 11 minus 15 is negative 4. We want to divide that by negative 2 in order to get y by itself, and that gives us the answer of positive 2. Now we want to check our work. We're going to do that using the top equation there. So I'm going to do 2 times 3 minus 5 times 2. We want to make sure that that equals 11, right? So I'm going to plug into my calculator 2, open parentheses 3, close parentheses, minus 5, open parentheses 2, close parentheses, hit enter. And I got a 4. I got a 4 this time. 2, open parentheses 3, close parentheses, minus 5, open parentheses 2, close parentheses, enter. I got a negative 4. So that is not a true statement. So I must have done some of my work wrong in this case. So we need to go back and look at this and see what we did wrong. Okay, positive 2 times a negative 5 makes a negative 10. Negative 5 times a negative 2 makes a positive 10. So I think that I'm on the right track for this. Let's make sure I did my other work correctly. 2 times 2 is positive 4. 2 times negative 4 is negative 8. Negative 5 times positive 5 is negative 25. Negative 5 times 11 is negative 55. 4 minus 25 is negative 21. Negative 8 minus 55 is negative 63. divided by negative 21 is positive 3. Okay, so 5 times 3 is 15. 5x minus 2y equals 11. 5x, x is 3, okay? So then 11 minus 15 is negative 4 divided by negative 2 is a positive 2. I still got the same answer. Oh, this is my problem right here. I put 2x minus 5y equals 11. That's what I put right here. What does it say our actual answer is? It says it should be negative 4. So I actually got that correct. It should be negative 4. Okay, but it's always good to check your answer just to be 100% sure you got the correct answer. And I am 100% sure the correct answer is 3, 2. All right, so we're on to this equation. Give the characteristics for the graph below. So what is the rate of change? The rate of change is the same thing as the slope, or the M equals, okay? Remember, that's also known as rise over run. So it's relatively easy when you have a graph to figure this out, rise over run. You just need to find 2 points. The 2 points I'm going to use are right here marked in orange, and that's the point 0, 0 and the point 2, 10. Okay, so rise over run. How far did it change vertically over how far did it change horizontally? So we went up 10, and we went to the right 2. 10 over 2. 10 divided by 2, that is 5. The rate of change is 5. Amount charged, I think that's in dollars. So in the hours worked, amount charged hours work is $5 per hour. All right, so find f of 6. So you're just going to go, okay, well, f of 6, this is the x value, since it's inside the parentheses right here, and we're going to go up and look at this. Okay, it is 30. F of 6 is $30. Using the graph to the left, find the domain, find the range, the x-intercept, and the y-intercept. So the domain is going to be all this down here, everything on the bottom, all of the possible inputs that you have. In this case, all possible hours worked. Well, the total hours worked could go on to infinity. It doesn't tell us that there's a limit of per year, per week, per month, per day. So it could be any amount of hours worked. So it can go to infinity. However, there is a limit on the lower end. There's a lower limit. You cannot work a negative amount of hours, right? It is possible for no one to work any hours. That would be 0. So that is possible, but a negative 1 hour, not possible. So we know the lower limit is 0, and we know the upper limit can go to infinity. Now, if it's going to be included, we want to use square brackets. If it's not included, we want to use the parenthetical bracket or parentheses. So we know that 0 is a possible outcome, so we're going to use the square bracket right here. Infinity, is it possible to include infinity as an answer? Well, no, you can never contain infinity. It just goes on forever and ever, so there's no way to possibly use infinity. So we're going to put the parenthetical bracket there, okay? Range, this is range, the y value. So again, it can keep going up as high as possible depending on how many, what the input value is. The output value keeps going up no matter what. But is there a lower limit to it? Well, there actually is. We cannot go below 0. If you notice, 0 is a possibility. If there are 0 hours worked, then there's 0 amount charged. So our range is going to be 0 to positive infinity, just like the domain. Our y-intercept, where does this graph cross the y-axis? Well, it crosses at this point, 0, 0. Where does the, oops, that was for y-intercept, but it's the same either way. This is our x-intercept here. Where does it cross the x-axis? It crosses at 0, 0 as well, right here. So those answers are the same. I had them in the wrong order. Is this graph increasing or decreasing? Well, it has a positive slope. You're going up a mountain. This is considered increasing. It's end behavior. Well, on the left, as x is approaching negative infinity, f of x is approaching what? That means what's the lowest it can possibly get? When it's moving to the left, what's the least that it could possibly do? Remember, that's going to be 0. So for a right end behavior, as the graph is moving to the right, as x is approaching infinity, what is y doing? Well, y is going on to infinity as well. I have our answers written here in orange. 3, 2, which is correct. 5 and 30, which is correct. There we go. B, it says range 0. I must have not put in B correctly because that should say C and D are 0 and 0. And 0 and infinity. There we go. Moving on to the next one. We have here, we are asked to, this word problem, a change purse has 60 nickels and dimes in it. So we know that there are 60 nickels and dimes together. It reads as if it's just 60 nickels, but it's because of the break here in the line, but it's 60 nickels and dimes. Nickels and dimes. So nickels and dimes there's 60 of them, right? And is a key word that tells us to add. Nickels and dimes are 60. There's 60 of them, okay? The coins total $5. Well, I know it's going to equal $5, so I need to know the value of each of these coins in order to figure out how many of each I have. Well, a nickel is 5 cents, so 0.5, oh, nope, that's 50 cents. 0.05 N plus 0.1 D. That's all squished together. I don't like it. I'm going to rewrite it. D 1.0 plus N 500. Okay, so here we see 5 cents for every nickel and 10 cents for every dime. Remember, 10 is because there would be a 0 after this. It's implied. So 0.05 times N times how many nickels we have plus 0.1 D, which stands for how many dimes we have, equals $5. Now, using this, we've just created a system of equations here, and we're going to use the system to find the information we need. We need to know how many of each coin is there inside this change purse. So, and what we need to do, in my opinion, the easiest way to solve this is to solve by substitution. So I'm going to solve this for, we'll just say D equals 60 minus N. Okay, so we changed up this equation. It is now D equals 60 minus N, and I can substitute that in where the D is. So I'm going to have 0.05 N plus 0.1 times, instead of D, I'm going to put in 60 minus N equals $5. Now, in order to solve, my first step is to simplify, and that means, in this case, I have to start with distribution. So 0.05 N plus 0.1 times 60. Always use your calculator. 0.1 times 60 equals 6. So I don't need to write out the multiplication problem because I did it in my calculator. 0.1 times 60 is 6. And then 0.1 times negative n is negative 0.1 n equals 5. Now I want to combine my like terms. And if you notice, I have an n here and an n here. So my like term is going to end with an n. And now I need to combine my coefficients. 0.05 minus 0.1, okay? And that's going to give me a negative 0.05. 0.0, negative 0.05 N plus 6 equals 5. So continuing on, 0.05 n equals 5 minus 6. If you notice, I took my 6 from the left and I moved it to the right. When I change sides, I have to change signs. So it moved from a positive to a negative. So 5 minus 6 is negative 1. So I've got 0.05 n equals negative 1. And now in order to get n by itself, I'm going to divide negative 1 by negative 0.05. And I'm going to get 20. So n equals 20. So I know that my nickels equal 20. Well, how can I figure out how many dimes I have? Well, I know that dimes equal 60 minus n. So I'm just going to put into my calculator 60 minus 20, and I get 40. So I know that I have 40 dimes. All right, so graph the inequality. Y is greater than x plus 2. This is already in y equals mx plus b format. So we know that b is going to be 2 and m is going to be 1 over 1. So b is 2. I know that my first dot is 0, 2. That's my y-intercept. My slope is 1 over 1. So I'm going to go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. Same thing in the opposite direction. I can go down 1 to the left 1, down 1 to the left 1. So here is my line. Now I need to know what is it that I'm supposed to graph to shade in for this. Oh, that is not my line. If you notice, I have a greater than symbol. So my line is actually dashed, or some people call it broken instead of a solid line. That means my answer cannot be found on this line. Okay, the line is just the boundary of where my graph is going to start or end. But my answer cannot actually be found on a dashed or dotted or broken line. Now, how do I know which side to shade? Am I going to shade this lower side or this upper side of y? Well, it says y is greater than, and if we look at the y, these numbers are less than and these numbers are greater than. So we're going to shade this side right here. And since this is a test, I do want you to pick a number to try and make sure that that is correct. I like choosing 0, 0. So if I plug this in, 0 is greater than 0 plus 2. Since this is on the side that is not shaded, we should get a false statement. So 0 is greater than 2. Okay, that is false. So our answer checks out. You could choose a number on the positive side here, the shaded sign, in which you would want to make a true statement. All right, so here we're going to graph this inequality as well. And we have 2x minus 3y is greater than or equal to 6. In this case, we're going to have a solid line because of that equal sign right there underneath it, instead of the dash line like we had on the last one. Now, this inequality is not in y equals mx plus b format, so we're going to just switch some stuff around here. I'm going to have negative 3y is greater than or equal to 6, and then I'm going to have minus 2x. I took my 2x over here and I moved it to the other side. I moved it from the left to the right, so it changed from a positive 2x to a negative 2x, okay? Now, I need to multiply or divide in order to undo y, which means I have the possibility of having to switch my inequality symbol. So I need to pay close attention whenever I multiply or divide anything when working with inequalities. In this case, I am going to be dividing by a negative. So I know I need to go ahead and switch my inequality symbol so that I can be sure to get the correct answer. Negative 3y, so that means I'm dividing by a negative 3 on both sides. So negative 3 divided by 3 is just 1, so it's going to be just y. 6 divided by a negative 3 is a negative 2. Let's use our calculator. 6 divided by negative 3 is a negative 2. Looks like a z, but it's a 2. And then negative 2 divided by a negative 3 is a positive 2/3 x. Now, this may be in a different order, but we can still identify the m and the b. The b in this case is the constant, so b is negative 2, and m in this case is the coefficient before the variable. So m is a positive 2/3. So b is negative 2 right here. And we're going to go up 2 and over 3. So here is our line, and let's verify it's supposed to be positive. Yes, we did say that earlier. It's supposed to be positive because it is greater than or equal to. Now, do I need to graph the top or the bottom? Well, that depends on how I got my y. My y here is less than or equal to this, and so which part of my y-axis is less than? Well, these numbers are greater than, and these are less than this dot, right? So this is going to be my side that's shaded right here. And I want to verify this. So this time I'm going to pick something in the shaded region to verify. Let's see, 1, 2, 3. Let's do this one. That is 4, 0. That's the point 4, 0. So let's plug this in to our original equation right here. So we've got 2 times 4 minus 3 times 0 is greater than or equal to 6. 2 times 4 is 8, minus 0 is greater than or equal to 6. Is 8 greater than or equal to 6? It is. It's true. And so that verifies that we got this correct. Oops, I already had the answers showing here for us. I did not realize that I had done that. All right, here we go. We have got 3 more problems for us. Which region is the solution for the following system? So there's a few ways that you can do this. The first way is you could solve for y in order to go ahead and shade this, or you can just pick some points on here and plug it in and see what works and what doesn't work. I want to solve for y because to me it's just as easy. So I'm going to go ahead and solve for this second one right here, and it's just y is greater than or less than 2 minus x. So I know that 2 is b, and then my m value is -1 over 1. So this is my line right here. This is going to be my green line right here, green line. And I know y is greater than, so I know that it's going to be shaded on this side because 6 is greater than 2, right? So I know that my y values are supposed to be greater than on that line. So that is what's shaded there. Now, let's look at this other equation here. Let's solve for y on this one. This is -4x plus 2y is greater than or equal to 20. So we're going to have 2y is greater than or equal to 20 plus 4x. It switched sides, so it has to switch signs. Now I need to divide everything by 2. Y, this is a positive 2, so I'm not going to change my sign at all. Y is greater than or equal to 10 plus 2x. So this is 10, and we're going to go down to, up 2 and over 1, up 2 and over 1. So if we go down 2 and to the left 1, that's the same thing. But the line is already graphed for us, so that's not the important part that we need to look at. But I do like to verify that the line is correct. Now, y is greater than or equal to this line. So let's look at this. Where is the y value going to be greater than this line? Well, it's going to be greater than this line above. So I know that this is my shaded side. And so where do these shaded regions overlap? Which region is the solution for the following system? A, B, C, or D? Well, B right here is where they overlap. So B is my answer. B. Okay, so this one's going to be a lot easier because it's already set into the y equals solve for y area. So I just need to verify which of these equations matches. So y is less than or equal to x. In this case, b is going to be 0 and m is going to be 1 over 1. Okay, in this case, b is still 0 and m is -1 over 1. So the red one is the one with the positive slope and the, if you notice right here, the solid line. So this is my red one, right? And then my yellow equation is the one with the negative slope. And if you notice, there's no equal sign under there. So it's the one with the dashed line. Okay, so let's look back at this red one. Y is less than or equal to the solid line. Y is less than or equal to the solid line. Where is y less than it? Well, it's less than down here because -8 is going to be less than 0. So this is the side that's going to be shaded for the red equation. Let's look at the yellow equation. Y is greater than whatever the line is. Y is supposed to be greater than that line. So let's look at the Y values. Where is Y greater than this line? Well, where it crosses is at 0. So is 4 greater than it? Yes, it is. So this is where the Y crosses. So where is our answer? In what section? It's in the C section right here. So C is going to be our answer there. All right, so let us look at this last one. Which point is a solution to the system? Okay, well, I'm going to jump down here to these last two, x and y. X is less than 0 and y is greater than 0. It can be less than or equal to, greater than or equal to. So let's just look at the x values. Every single x has to be negative if x is less than 0. So I already know that that's not going to be 1, and that's not going to be 1, and that's not going to be 1. So just looking at this part of the system of equations right there, I'm able to eliminate 3 possible solutions. Y has to be greater than or equal to 0. Is 1 greater than or equal to 0? It is, so that checks out. So we've got 2 equations. We've already gone down to just one answer. But I want to make sure that this is actually the correct answer. So what you need to do is plug this into both of these equations to see if it works. So let's plug it into the first one. Instead of y, we're going to write 1 is less than or equal to -5 plus 2. Okay, now we're going to use our calculator. -5 plus 2 equals -3. Is 1 less than or equal to -3? No, 1 is greater than -3 because it's a positive, right? So it's not true for this statement. So that means it's also not a solution. I don't even need to enter it into this one because I already know that it made this statement false, so it cannot be a solution. So there is no solution for this problem. Which point is a solution to the system? The answer is none. B is B, C is C, and this answer is none. All right, the drama club is selling tickets to its play. An adult ticket costs $15. Let's call the adults X. And a student ticket, let's call students Y, cost $11. So A, adult tickets cost $15. $15. Y, student, I put A, even though I just said it's going to be X. Let me clear this real quick. X is $15, right? And Y is $11. I'm doing that because the 11's on the second line and it's hard for me to see. So I'm going to just write my X and my Y again. X and Y. Y and X. All right, the auditorium will seat 300 ticket holders. So X plus Y has to be something to do with 300. Is it going to be greater than or less than 300? Well, it can be equal to 300, but there's got to be something else. Can I fit more than 300 people or do I have to fit less than 300 people? Well, I have to fit less than 300 people in an auditorium that can only seat 300. So X plus Y has to be less than or equal to 300. All right, so then the drama club wants to collect at least 3,630 in ticket sales. What are the constraints? I remember this problem from the lesson. This is the exact same problem in the lesson, I feel like. Oh, it tells us X is the number of adult tickets, Y is the number of student tickets. I'm glad I chose those because that's the exact same they had. So 15X plus 11Y, and it's going to do with 3630. Now, it says they want to collect at least this much money. So what would be greater? Would they collect or that number? Well, what they collect, they want to be greater. So it's going to be that way. And it says at least. So are they going to be happy if they get exactly $3,630? They will be happy. So it's going to be greater than or equal to. So which one of these for A, B, C, or D is going to have our 2 equations? So the first one is X plus Y is less than or equal to 300. We know it's not this one. Less than or equal to, nope, not that one. That's a possibility. Not that one. It looks like we have our answer. Let's just verify the lower equation just to make sure. 15x plus 11y, 15x plus 11y is greater than or equal to 3630. All righty, there we go. And that is what the question was, answer was. All right, so here we are. We have f of x is -5 plus 1. G of x is 7x plus 4. And h of x is 2x squared plus 3. J of x is 2/3 x minus 1. Now, we're supposed to use all of this information to answer problems 18 through 21, which should say 17 through 20 for whatever reason. I don't know why these numbers are always off. All right. All you have to do is take this number and plug it in where you're going to see the h equation here. Okay, so h of -3 is 2 -3. Make sure you put it in parentheses. And that's very important, especially when you see the squared right there and you have a negative number, because -3 times -3 is completely different than -1 times 3 times 3. Now you're like, well, Miss Andrea, why would you say -3 times 3 times 3? Because if you put -3 squared into your calculator, it's going to read it this way. So you have to put -3 inside parentheses and square it in order for it to read it that way. Because all the calculator sees for the squared is what's exactly in front of it. So it thinks all you're squaring is the 3, and that negative is just an implied number 1 multiplied by the whole thing. So in order for the squared to apply to the 3 and the negative sign in front of it, it has to be inside parentheses. So it's very important to make sure you have that correct. So I'm going to go ahead and plug this into my calculator. I'm going to enter just the left side of the equation. And let me rewrite this down here for you, because since that's on a line, that's hard to see. I'm going to do h of -3 equals 2 times -3 squared plus 3. So I'm going to enter just this left side of the equation into my calculator here. 2 open parentheses, -3. And remember, you have a special negative button on your calculator that's different from the minus sign button. So you have to make sure you use the -3 or else you're going to get an error message, okay? So again, that was 2 open parentheses, -3 close parentheses squared plus 3, enter. And I got 21. So h of -3 is 21. All right. Now let's look at 18. J of 9. So again, we're going to do the exact same equation here, and we're going to plug 9 in. J of 9 equals 2/3 and then 9 minus 1. Now, when you're entering into your calculator, if you're unaware of how to use a fraction on your calculator, the easiest thing to do is just to use your division symbol and put it in parentheses. So we're going to start with open parentheses 2 divided by 3, close parentheses. Open parentheses 9, close parentheses, minus 1, enter. And we get 5. So J of 9 is 5. So moving on to number 19. And so this is g of x minus f of x. So we're going to start by writing what our g of x equation is. It is 7x minus 4. And then it says minus f of x. So we're going to do minus, and then we have to put this in parentheses because of our subtraction sign here. We need our f of x, which is going to be negative 5x plus 1. Now, when you have a subtraction in front of a parentheses, the subtraction is going to change all the signs of everything inside the parentheses. So we have to distribute it. In other words, we distribute the negative to this first one. So 2 negatives is going to make a positive 5x. We're going to distribute the negative to the second one. So a negative and a positive create a negative 1. So now we have 7x minus 4 plus 5x minus 1. So we need to combine our like terms here of x. And then a positive 7 and a positive 5. 7 plus 5 is 12, 12x. And then we need to combine our constants here, a negative 4 and a negative 1. So I'm going to put negative 4 plus negative 1. And I typed that wrong. Negative 4 plus negative 1 is negative 5. So negative 5. And so my answer is g of x minus f of x is 12x minus 5. That's how you would write that. And this is your final answer. Now, moving on to number 20. We're supposed to find x. What is x? If g of x is 17. So that means we need to place this 17 all the way where this g of x is, right here. So if g of x is 17, we're going to substitute that 17 where the g of x is and solve for x. Okay, so we're going to have 17 equals 7x minus 4. Now we solve for x. So I'm going to have 17 plus 4 equals 7x. My minus 4 switched sides from the right to the left, so it had to switch signs from negative to positive. 17 plus 4 is 21. 21 equals 7x. I need to divide both sides by 7, and I'm going to get 3 equals x, which is the same thing as x equals 3. So that's my final answer. Let's see if we can circle all of our answers and see if I have them written out for us. Where's the answers? Here they are. Let me erase what I wrote so we can read them. All right. So we have 21, 21, 5, 5, 12x minus 5, 12x minus 5, and x equals 3, x equals 3. So far, we've gotten everything right. Robbie is getting better at math. I feel like I've had this question before too. Robbie is getting better at math. On his first quiz, he scored 57 points. Then he scores 61. I'm going to write these down. 57, 61, 65 on his next 2 quizzes. So 2 65s. If his score continues, it's not saying 65 on 2 quizzes, it says 61 and 65 on his next 2 quizzes. So if his score continues to increase at the same rate, what will his score be on his 9th quiz? Show all work. All right, so if I remember correctly, these increase by 4. Let's see, 61 minus 57 is 4, and 65 minus 61. Again, I encourage the use of calculator for all answers on your test, even if it seems very simple to you. All right, so we're supposed to write an explicit formula. And remember, our explicit formula, f of 1, is, f of n. When you're writing formulas, it's for the formula f of n. So in other words, whatever number you're looking for, your formula can be found through f of 1, which means the first number, plus the difference times n minus 1. That was our explicit formula. You should have that written on your note cards. All right, so we need to figure this out. That means f of n is, our first term was 57, plus the difference, what's our difference, is 4 times n minus 1. I'm actually going to write this down here because I know that they want it simplified, even though they didn't tell me to. I know that's just how they are. All right, so f of n is 57 plus, let's distribute out this 4n minus 4. So f of n is 57 minus 4. 57 minus 4 is going to be 53 plus 4n. So I want to write my answer up here. F of n is 53 plus 4n. That's my explicit formula. Now, what is a recursive formula? A recursive formula, remember, is going to use the last term. So you still start off with f of n is, but instead of the first term, we want to use the last term or a previous term. So you're going to say instead of f of 1, you're going to say f of n minus 1, and then you just have to add the difference to it. Now, when you have this, you have to tell us what the previous term is. So in this case, we can just start with f of 1 is 57. That's going to be the first part of our formula. It does have to be included in the answer. So let's look at this. If we say, well, we're going to have f of, and I don't even have to write anything, f of n minus 1 plus the difference 4. So this is our recursive formula. You have to have both the information given plus the formula. This is our explicit formula here. Now, to get to what was actually asked of us, what is his score on the 9th quiz? So we want to put f of 9 into one of these equations. F of 9. So f of 9, I want to use this top equation equals 53 plus 4 times n, 4 times 9. So I'm going to plug that into my calculator. 53 plus 4 times 9 equals 69. It should 53 plus 4 times 9. Oh, I couldn't read my calculator. That's 89. F of 9 equals 89. I knew 69 didn't sound right. 89. All right, so F of 9 is 89. There we go. Let's see. 53 plus 4n, 53 plus 4n, there we go. And f of 1 is 57, and f of n is f of n minus 1 plus 4, and f of 9 is 89. We got all of those correct. All right, and this is our last equation. Looks like I already have the answer up for you. So I forgot to hide that, I'm sorry, but we're still gonna work out the answer here. The population of deer in a park has grown over the years. The table below gives the population for a survey by local wildlife officials. Find the average rate of the deer population that is changing over the time interval from 2000 to 2006. So we want to look at 2000 to 2006. So the rate of change, what we just have to think of is what is per? Is it year per deer or deer per year? What's going to be deer per year? So I want to put the deer on the top and the year on the bottom, because remember the division symbol tells me per, right? So deer per year is how I want to put my answer. So I want to find the difference between the deer 264 in 2006 minus 168, 168. Okay, and then my year change is 2006 to the year 2000. All right, so I'm going to plug into my calculator the difference in the deer. 264 minus 168. That's 96 on the top. And then I know that the difference in years is 6. The difference between year 2000 and the year 2006 is 6 years. So 96 divided by 6 is 16. So I get 16 deer per year. That's the average rate that the deer population is changed between the years 2000 and 2006. 16 deer per year. All right. I know y'all did great. I'm sure you got 100. You got all of these right on the review, and I expect you to do just as well on the test. Remember to use your calculator and check your work.